Good morning, everyone. So we are doing coordinate geometry, and in coordinate geometry, we have discussed the distance between 2 points. That is the distance formula. Then we have discussed the point distance from the origin. We have discussed midpoint formula, and one very important thing which we have discussed, that is the gradient of the line, or that is called slope of the line. So we have discussed all these, and we are doing the exercise. We have finished with the first question. So let's take the second question of the exercise. Second question is, for some parts which we have discussed, only four parts we have discussed. We can do the first question number one again. First point, let's take it 5 2. Points are 5 2, and A point is having vertices 5 and 2, and B points vertices, they are 2 and 8. So 2 and minus 8. And the second, let's take second portion, A point, that is minus 6 3, and B point coordinates, they are 6 and 3. So first, in both the parts, we will find first the gradient of the line AB, then midpoints of the line AB, right? So first we will find the gradient, right? That is the M, we denote M. So it is y2 minus y1 upon x2 minus x1. So we have here minus of 10 upon minus 3, right? Minus of 10 upon minus of 3. So what is the gradient? Gradient is equal to 10 by 3. So gradient here is 10 by 3 is the gradient. Next is the A part. In B, we want to find the midpoint of the line segment joining AB, the midpoint. So midpoint x is equal to your 5 plus 2 divided by 2, and y is equal to 2 plus minus of 8 divided by 2. So what are the points? The midpoint M is having coordinates x, that is 7 by 2, and y, that is minus 6 by 2 is minus 3, right? So what is the midpoint of the line segment AB, where A is the point 5 and 2, and B is having the coordinates 2 minus 8. So midpoints are 7 by 2 comma minus 3. Next, the distance AB. See, we are interested to find the distance AB. Distance AB is under root x2 minus x1. So here that is 2 minus 5 whole square plus y2 minus of 8 minus 2 whole square. So here is 3 whole square, that is 9, and here 10 whole square, that is 100. So here what is the AB? AB is equal to, that is under root 109, right? So it is near about 100, sorry, 10 something, because 10 square is 100, right? And last, they have asked the gradient of the line which is perpendicular to AB. So gradient of a line, see last part, we know the gradient m1 into m2, right? One is 10 by 3, 10 by 3 into m2 is equal to minus 1. So gradient at m2 is equal to minus of 3 by 10. That is minus of 3 by 10. So in the same way, we can solve the second, that is the A part here. First part, that is gradient m, that is equal to y2 minus y1. So y2 minus y1, 3 minus 3 is equal to 0, and divided by 6 minus we get plus 6. So it is 0 by 12 is equal to 0, right? What is the slope of the gradient of the line segment AB? That is 0. Next, that is use the midpoint, that is M. In this case, midpoint is the coordinate, x and y are the coordinates. So x is equal to minus of 6 plus 6 divided by 2. So here that is again 0, and y here, that is minus of 3 plus 3 divided by 2, that is 3. So what is the midpoint? Midpoint's coordinates are 0, 3. And the next, that is the distance formula. The distance AB is equal to under root. So 6 minus 6, then that is 12 whole square, plus 3 minus 3, that is 0 whole square. So here the distance formula, that is under root 144, that is 12 only. So what is the distance of AB? The line segment AB is of 12 units, right? By using distance formula. And last one, the slope is 0. So m1 m2 is equal to minus 1. m1 is 0 into m2 is equal to minus 1. So what is it? This is the slope that is infinite. M2 is equal to minus of 1 divided by 0, that is infinite, right? So line slope, that is perpendicular. So one is the slope of the line AB, that is parallel to x-axis. So perpendicular, that is having slope, infinite slope, right? So this is about the first question. Come to the second question. Let me write the question for you. Question number 2 is the line joining. Question number 2, the line joining the line joining the points P, that is 3, minus 4, and 2Q. Q coordinates, they are writing here small q, 0, has the gradient 2, has gradient 2. Find the value of q. Find the value of q. Find the value of q. So we know solution here. We have studied that the gradient of a line, that is y2 minus y1 upon x2 minus x1, and this gradient that is given 2 is equal to y2 is 0 here, 0 minus of 4 plus q into q minus of 3. So here when we cross multiply, this implies that 2q minus of 6 is equal to plus 4. So here this implies that 2q is equal to 10 and q is equal to 10 by 2. So here the value of q, that is 5. What is the value of q? Q is equal to 5. This is asked here. Gradient is given. We have Jaswinder very okay. No problem, dear Jaswinder. Okay. So here we have found the value of q, that is 2 here. Then come to the next question. Next question is question number 3. In question number 3, 3 points are given. Question number 3, 3 points are given x, y and z. Question number 3, 1 point is x. X coordinates are 2 minus 1 and y coordinates are a comma y here and z coordinates are 11 and 2. What is the question? These 3 points are collinear. Are collinear. Are collinear. These 3 points are collinear. Collinear points means they lie on the same line. Find the value of y. Find the value of y. These 3 points, x coordinates 2 minus 1, y coordinates 8, y and z coordinates 11 and 2. Find the value of y. Find the value of y. Find the value of y. So here we know it is the same. These 3 points, they lies on the same line. Means x, y and z, they lies on the same line. So what we will do? We know their gradient remains the same. The slope of the line segment x, y, y, z and x, z, that remains the same. So we can use this property of the gradient or the slope. So here we can start here, right? M1 solution is M1, sorry, a slope M, that is equal to, here if we write, this is a x1, x2, y1, y2, so we have y2 minus of minus 1 upon x2 minus of 2, this is equal to, we can take these 2, here it is y minus, or we can take the third also. If you want, you can take even yz also or xz. If you want xz, then no, y will not come. But you can choose any of the value, you will find the value of y same. Like here, if you are taking 2 minus of y, and here 11 minus 8. So we will solve it. What is left here? We have left here y2 plus 1 divided by 6 is equal to 2 minus y divided by 3. So when we cross multiply, we got 3y2 plus 3 is equal to 12 minus 6y. And here just cross multiply, not just interchanging the sides. 6y becomes here y2, we will not write simple y here, there is no need to write y2. Okay, variable is y here. So here we have 3y plus 6y is equal to 12 minus 3. So we have what we have, this implies that 9y is equal to 9, and we have y is equal to 1. Please check question number 3, the value of y that is equal to 1. So next we have the next question, question number 4. We have the 4 points they are given. Question number 4, the points A, B, C, D have the coordinates. The points A, B, C, and D have the coordinates. Coordinates are 1, 2, next that is 7, 5, then 9, 8, then and 3, 5. Now three things they are asking. They are asking the gradient, find the gradient of AB, BC, CD. First part they are asking the gradient of AB, BC, CD and AD. First part is find the gradient of AB, BC, CD and DA. So we know how to find the gradient. For AB, the gradient M is equal to 5 minus 2 upon 7 minus 1. So that is equal to 3. That is equal to 3 by 6. So gradient is 1 by 2. Gradient of AB is 1 by 2. Now what is gradient of BC? BC is the gradient of BC, that M, that is equal to 8 minus 5 and 9 minus 7. So here it is 3 by 2 is the gradient. Then CD, the gradient of CD, that is 5 minus 8, 3 minus 9. So here gradient that is minus of 3 upon minus of 6, again that is 1 by 2. And last AD, the gradient of AD, that is the slope here, gradient that is 5 minus 2 upon 3 minus 1. So here that is also 3 by 2. So here the another parts, the 2 parts this question they are saying. First is what do the gradient tells about the quadrilateral ABCD. So you have to join the quadrilateral ABCD, right? ABCD. So here slope is half, right? ABCD, right? 3 by 2, right? So here ABCD in this way, ABCD here, this is the this kind of quadrilateral is there. So here you can plot the points A, B, C, D, and the last they are saying draw a diagram and check your answers to part second. So you have to plot the diagram on those coordinates. We know how to plot the this coordinates. If we have the x-axis and y-axis, this is suppose x-axis 0, 1, 2, 3, 4, 5, and here minus of 1, -2, -3, -4, -5, right? And here next always is 9 and 10 also. But let's start here with 1 and 2. -1, -2, 1 and 2. X is 1, y is 2. This is the point here, A point, right? And another point is 7, 5. X is 7, right? X is 7 and y is 5. So 1, 2, 3, 4, 5. So near about here, right? So this is your AB. Then 9 and 8. 9 and 8. So 9 and 8. So here it is 5, 6, 7. Near about here, right? This. And then 3, 5. Where is the point? There is point C. X is 3 and y is 5. X is 3 and y is 5. So point is near about here. So in this way, they have this is the quadrilateral, okay, and with having these slopes, that is 1 by 2 and 3 by 2, right? So next question number 5. In question number 5, again they are saying A, B, C are the points having the coordinates where B is greater than C and angle ABC is 90 degree. Right? If the coordinates are points A, B, and C have the coordinates. Question number 5, the coordinates, the point A, B, C have the coordinates are your 2, 1, B, here B, 3, and last is C, that is 5, 5. Have where B is greater than where B is greater than 3 and B is greater than 3 and angle ABC is 90 degree and angle ABC is equal to 90 degree, right? So here we have the 3 things to find. One is the value of B and the length AB and BC and the area of the triangle ABC, right? 3 things we have to find. First, we have to find the value of B. Second, we have to find the length of AB and BC, length of AB and BC, and third we have to find the area of a triangle ABC. Right? These 3 parts in this question we have to find. So how to do it? We know that 3 points, this frame 90 degree angle. So here the slope m1 m2, here B point, that is B, 3. First we have to find the slope that slope m1 m2 is equal to always minus 1. Slope, that is, here we have 3, that m1 is 3 minus 1 upon b minus 2, right? B minus 2 into this one into 5 minus 5 minus of 3 upon 5 minus b is equal to minus 1, right? Because angle B, point B, that is point B is a right angle. So we are applying m1 into m2 is equal to minus 1. So from here we can apply the value. This implies that we have 2 into 2, that is 4, and here we have b minus 2 into 5 minus b is equal to minus 1, right? So we have here, this implies that 4 is equal to minus, or yeah, either you can say minus of 4 is equal to b, when we open the bracket, b into 5 minus b minus of 2 into 5 minus b. So here we have 5b minus b square minus of 2, so that is 10, and minus of minus plus, that is 2b, right? So here it is 2b and it is minus of 4. So here what we have here all these number beside b square minus b square plus b square is a positive, changing the sides, then here it is 7b minus of 7b, right? And it will be plus 6. Now we have to factorize it. When we will factorize, we can take b square minus of 6b plus 6b, sorry, it is not a square here, it is 6b minus of b plus 6. So what is the concept here? Here we are taking the two values of b already. One is b into b minus 6. Here it is b into b minus 6, and here also b minus of 6, and here we will take the value minus of 1. So either b is 1 or b minus 6 is equal to 0 here. This is equal to 0, right? So either b is equal to 1, b is equal to 1, or b is equal to 6. These two values we have, so we can check for b is equal to 1 and b is equal to 6, right? So here AB and BC, so we will find the distance formula, that is for AB and BC, and the area of triangle ABC also. Area of triangle, because it is a right angle triangle, area of a triangle is half into area of triangle ABC is equal to half into base into height. That is base into height. Right? So here height is the altitude. One side is base and another side is the height. So in this way we have 2-3 more questions. So today we will discuss the today's concept, that is the next concept is related with the equation of the straight lines. That is, the next is equation of the straight lines, right? In this way you can solve. We have 6 question also in the same manner. They are saying PQR. PQR, what is this of a triangle, right? Triangle PQR has the vertices. Find the value R when the triangles. Let's take the 6th question also. Question number 6. Total this exercise is having 11 questions, right? Question number 6. Question number 6. Points PQR. In question number 6, point P coordinates, they are 8 and 6. Q points, the coordinates are 0, 2, and P points, coordinates are R points, coordinates they are 2, R. Now they are saying if point P is the right angle, if so many parts are there. So first, if point P is the right point P is the right angle. This right angle is there. Then find the value of. Now here if P is the point, right? Suppose point P is the right angle, and here one point is Q and one point is R, and R is having coordinates 2 and R. P points coordinates they are 8 and 6, suppose, and the Q points 0, 2, suppose. So here, if so by Pythagoras theorem, we know that the distance, that is AB, distance RQ whole square is equal to distance, that is QP whole square plus distance, that is PR whole square. We will substitute the value in these. For that we have to find what is first QR distance. So QR distance is under root here, that is 2 minus 0 whole square, that is 2 square, and next plus r minus 2 whole square, right? This is QR. So QR here is, that is under root 4 plus r square plus r square, or you can say r minus 2 whole square, you can write, because when we will go for QR whole square, then we will get, that is 4 plus r minus 2 whole square, right? What is QR whole square here, or RQ whole square, that is 4 plus r minus 2 whole square. Then next is your QP. QP is equal to under root 1 is your 8 minus 2, that is 6. 6 whole square is 36. And next is, sorry, it is 8 minus 0, that is 64. And 6 minus 2, 4. 6 minus 4 is 6 minus 2 is 4, 4 whole square is 16. That is under root 19. So under root 80. Right? So Q3 whole square, that is 80 here, plus PR. PR is under root 8 minus 2, that is 36, plus 6 minus r whole square. So here we will substitute the values here, that is 36 plus 6 minus r whole square. So we will solve for this first part. So this question will be little lengthy. Now second one, we have to find the value of r when the angle Q is right angle. And for the third part, when the point Q is 1, here P is right angle, R is right angle, and one side Q is the right angle. So here we have to solve the equation and we have to find the value of R, right? So this is our this exercise. You can solve in this way all these questions, right? So next topic, that is related with the equations, how to draw the equations of a straight line, right? The equation of the straight line, the equation of straight line. We have studied in your previous class that y is equal to mx plus c, where m is called the gradient of the line and c is called the y-intercept. M is called the gradient and c is the y-intercept, right? Y is called the y-intercept. Now here we have drawing a line given its equation. Some of the several standard form of the equations of the line, right? So here let me discuss first when we have a line parallel to y-axis. When we have a line parallel to, here we have a x-axis, y-axis. Okay? This is your x-axis and here is the y-axis. If we draw any line, suppose this is the point your 3, 0. Here is the line. This line, that is x is equal to 3, or any line which is x is equal to a is a line, always equation of line parallel to y-axis, right? This is the equation of line. Is this is a equation of line, parallel to x-axis, equation of a line parallel to y-axis, equation of line parallel to y-axis, right? Or any line in this form like x is equal to 8. This is the line always parallel to y-axis. Whereas if we have a line B, that y is equal to B, right? For example, here if we have a this is the equation of line. These are your x-axis, y-axis. This is your x-axis, and this is your y-axis. Then suppose here 0 2 here. Here is 3 0. This point is 3, like 1 2 3 4 so on, and here is 1 2 0. This line, this is the equation of line y is equal to 2. This is the equation of line y is equal to 3. So y is equal to 2 or y is equal to b is a line parallel to x-axis. Equation of line parallel to x-axis. right? This is the x-axis. These two lines, they are parallel to x-axis, and here the line parallel to y-axis, perpendicular lines, right? So this x is equal to a is a line parallel to y-axis, and y is equal to b is the equation of line parallel to x-axis. So next one, when we have the line, they are passing through the origin, right? C part, when the lines passing through the origin, then we have the equation, the lines pass through the origin. Line passes through the origin, right? When the line passes through the origin, this is the coordinates origin here, this is the x-axis, and right. So when the line passes through the origin, what will become, y is equal to mx only, right? I will give you one example. If a line is passing through like in this way, right? The line passes through. This equation is, if you plot y is equal to minus 4x, right? One more equation we can write, that is y is equal to half of x. Y is equal to half of x. Y is equal to half of x. We will plot the graph. These two lines, y is equal to minus 4x and y is equal to half of x. These two lines, if we plot their graph, that graph will passes through, the line will pass through origin, right? Okay, origin, right? Whereas when the lines, these lines intercept at the y-axis at other point, then we will have the value of c. Okay. Now, in the same way, when the equation y is equal to mx plus c, we have the equation y is equal to mx plus c. Suppose here, this is your x-axis and this is your y-axis, right? X-axis and y-axis. In these two cases, if the line starts from 0, 1 and 3, 0, suppose one line starts from here 0, 1 and here 3, 0, 3, 0, then this equation, this represents the equation of this line. Equation of this line will be y is equal to minus 1 by 3x plus 1. Y is equal to minus 1 by 3x plus 1. And if we have one another 0 minus 1 and 0 1, 0 1 here, it is 1 0 and 0 minus 1. If we have an equation of line this way, then the equation of this line, that will be y is equal to x minus 1. Y is equal to x minus 1. So these are the various forms of a line, and we have one more, another form, that is px plus qx plus r. One more last form which we have discussed here. These are the equations. So here I want to discuss, that is px plus qy plus r is equal to 0. Px plus qy plus r is equal to 0. How they are taken? If the points are 3 0 and 0 2. Here one point is and one point is here. This point is 3 0 and here is 0 2 coordinates, and the line, this line here, O is the origin, and this line is here, that is 2x plus 3y, 2x 2x plus 3y, 2x plus 3y minus 6 is equal to 0. Minus 6 is equal to 0. So these are the all ways there, and this is often the ideal way of writing the equation, right? So next we will study the line parallel to x-axis and line equation of the line y is equal to mx plus c, right? This is sufficient for today, and on this basis we have exercise 3.4. On this basis we will have the exercise, that is 3.4. So thank you very much, right? God bless you all. Stay safe and stay healthy.